In this video, we're going to take a look at a more advanced section of Visual Basic scripting. We're going to take a look at MacroPumps. A MacroPump, for those that have heard the term and haven't got a clue what it is simply a block of logic code which sits in the background of your controller, running consistently. It runs once, and then a fifth of a second later it runs again, and then a fifth of a second later it runs again. If the MacroPump script takes longer than a fifth of a second, it will end naturally and then run on the next fifth of a second interval. At no time will two MacroPumps be run together or one MacroPump run twice. There's a limit of one MacroPump for each profile that you have. In the controller, under Configuration State, there is a checkbox for Run MacroPump. If yours has not been turned on and you're just turning it on now, you'll have to restart the software in order for a MacroPump to take effect. Now, in order to turn on a MacroPump, first turn it on in the configure state like I just did, and then call up the Visual Basic script editor. Now let's open up a MacroPump. You can see in my Mach3 mil directory, and incidentally, this is off of Mach3 macros and then to Mach3 mil in my case. If you're using a profile called My Profile, then it would be located in Mach3 macros, My Profile. You'll notice I have a MacroPump.m1s. You probably do not. You will have to write a script and simply save it as MacroPump.m1s in order to use MacroPumps. Now, I've turned on a MacroPump, but whenever you change or save a MacroPump file, you have to restart the software because the MacroPump, unlike other scripts, is loaded once at startup. It is then compiled, stored in memory as a compiled program, and then repeatedly rerun. This is to save time, to make things more efficient and more robust in terms of error handling. So let's take a look at how a MacroPump operates. One way that we can do that is to simply do a test run. We know that this DRO here can be attached to with getDRO or setDRO. So let's take a variable. We'll call it var is equal to getDRO 0. And that will get this DRO, which is the X position DRO, which is 0. We can then say var is equal to var plus 1. So we'll increment it from whatever number is there. Then we'll do a setDRO 0, var. This program, as you can see, all it does is read in the XDRO, add 1 to it, and store it back out to the X. So then we save it, and we're ready to run a MacroPump. The MacroPump will run automatically on the next run of the program, so we'll exit the program, start it up again. Now, without pushing reset, the macro is actually running in the background. But Mach3 ignores many commands unless you are in a safe condition. And one of the commands that it ignores is setDRO. So we have to do a reset in order to be able to watch the MacroPump operate. Now you can see that the XDRO is now counting several times a second. And it's doing that because it's been told in the background to keep on counting. Now you'll also notice that it keeps reverting back to another number. This is because I'm using the XDRO. There's all kinds of processes within Mach3 that use that DRO. So the MacroPump is being overridden. It does not have a high priority. MacroPumps have a low priority, and their purpose is simply to run in the background and do housekeeping tasks. It's much like informing a butler that if he sees an ashtray that's dirty, to empty it. And the MacroPump simply looks at the logic you give it and performs those commands repeatedly. So as you can see, it's just constantly counting. If I was to jog right now, you can see it doesn't really interfere too much with the jogging until I stop. If I jog my y-axis, you'll notice that the x-axis stops. This is because other more high priority tasks have control of that XDRO, but in actual fact the MacroPump is still running even though I'm doing this. Let's prove that point. by looking at our Settings tab. If you remember from a previous video, this DRO, the Tool Change Location X, is actually user DRO number 1200. So let's take a look at our MacroPump again. We'll load it up. And let's change Get DRO to Get User DRO 1200. And then we'll set User DRO 1200 to var. And we'll save this, exit, and now we have to restart the program in order for that to take effect. And here we are. We can see now that our X and Y DROs are being left alone to do their job. And if we take a look at the Settings tab, you'll notice one thing right off. It's going much faster. Now the reason it's going faster is because the DRO that we're writing to doesn't have other processes interfering with it, and it's allowing the MacroPump to do its job. And at the moment it's running probably 5 times a second, which is about the default time that I've told it internally. So at this counting rate, that DRO is able to look at conditions and do things as it wishes. We picked a DRO which I can't jog here on the screen at the moment, so I can't show you that this thing is actually doing its job even while I jog. But let's load a program instead so that we can see what it's doing. We're going to load a Scorpion. We'll zero our controls and regen our toolpath. So here's the Scorpion that we would normally be looking at cutting. Hit cycle start and you can see the program begins to do its function, and now it's cutting the Scorpion. And if we look at the Settings tab, you'll notice that the tool change location is still counting fairly quickly. It doesn't make any difference if you're running a program or what you're doing. In actual fact, the MacroPump continues to do its function in the background. And this can be quite a complex function. Normally it's used to look at variables and perform various interactions. For example, you could ask it to look at what's coming in from an MPG and use that value to affect a feed rate override. Some people have done this with potentiometers hooked up to a DL5 or other PLCs. And by reading the analog value coming back from that potentiometer, you can simply write a script routine which then tells the feed rate override to change. There are script calls for many of these items, such as set feed rate override, read macros, etc. It is given a low priority so that it does not affect running G-code jobs. It is simply meant to be always running in the background, watching what's going on, and responding to what's going on with your commands. There will be a new list of published functions. It takes me a while, unfortunately, to generate these functions. And one of the reasons it takes so long is because it takes a while for me to call them out from the code. I tend to write these things on the fly. And if we take a look at Mach 3's base code, here is the scripter. And as you can see, there is quite a list of script calls that you can call. All of these are commands which can be called in Visual Basic, which control Mach 3. I will be publishing this list of commands, and you'll get most of them by looking at other people's macros. So one of the smartest things that you can do, should you wish to experiment and write more complex scripts for a MacroPump, is to look at other people's code. Always a great thing to do when you want to see how something is done. Just load up your script editor, and you can not only just load the code which is in the macro directories, but you can also load code by looking at it from inside of buttons which are on various screens and wizards to see how they do their job. Most of the commands that you'll find inside your macros directory are pretty simple. M559 would be an example of one which is not simple. This is the write wizard. It is the code which does a lot of the drawings for the letters in the write wizard. So you can get an idea of just how complex a macro can be by looking at this. German Bravo, who wrote this absolutely amazing macro, spent a lot of time and a lot of hard work to do so. But you'll see scattered throughout it commands which Mach 3 recognize and which are not normally part of Visual Basic, such as set user DRO 1072. This one we're familiar with. But you have close teach file, load standard layout, load teach file, all kinds of commands which you will need to do certain functions. There are Modbus calling commands. There are commands to read parameters from the program, such as your acceleration and your velocity. But this video is really just meant to show you quickly what a MacroPump is and how to turn one on. And I think that at this point, you should know what a MacroPump is. You should be able to do a quick example to see how to operate it. And it's a start to writing your own MacroPumps. And we'll do more on those as I release the documentation with the more complex calls. That's it for MacroPumps.